All right, welcome back. This is video 12H. I'm going to do some more things with the normal distribution. This could be a little bit of a longer video, so let's get started. Grocery shoppers are likely to bypass apples that weigh less than 80 grams. They're too small for grocers. So the current genetically modified Granny Smith plant produces fruit that averages 100 grams, but 10% of those apples are too small. So 10% of them must be less than 80 grams. Is it reasonable, or it is reasonable, to assume a normal model applies? What is the standard deviation of the weights of apples currently being grown? All right, a little different than what we have looked at before. So first, let's start off with some pictures. We've never found this. What's the standard deviation? Usually it's what percentage or what's the weight of an apple that falls at a certain percentile there. So this question's a bit different. So we do have a normal model, draw what you know. So I'll start with the fact that we know that these apples follow a normal distribution with an average weight of 100. So we have a normal model, the average weight is 100. I do not know the standard deviation. So that's what we know. What else do we know? 10% of them are too small, and too small is weighing less than 80 grams. So if this is 80 grams, 10% of them, this area right here, would be 0.10. 10% of them are too small. 80 grams is the 10th percentile. That would mean that 90% of the apples weigh more than that amount. Okay, still doesn't help us find that standard deviation. Let's see if we can use the standard normal model to help us with this. So this was Y, this was the weights of the apples. Below this, let me draw the standard normal model. At the standard normal model, that'll be centered at 0. This is Z. Normal model 0, standard deviation of 1. And I could try to find the Z-score that corresponds to a weight of 80 grams. I don't know what it is, but I can see from my picture it's going to be negative. So I could try to find this Z-score. For that Z-score, the area to the left is also going to be 10%, 0.10. And the area over here will be 90%. And if I could find that Z-score, I could figure out the standard deviation. You might say, well, how is that? Recall what the formula was for a Z-score. If I knew the Z-score of that apple right there, that Z-score corresponds to a weight of 80 grams. We know the mean is 100. And then I would have everything, all the variables filled in my Z-score equation except for sigma. So I could solve this for sigma. So I need to find that Z-score, and once I found that Z-score, I'm going to come back and I'm going to use this, fill in everything that I know, and solve for the standard deviation. Okay, so I got to get that Z-score. When I come back, I'm going to have erased my pictures here, and I'll pick up with this formula. To find that Z-score, we're going to use the StatCrunch tool. So let's go to StatCrunch and find out what that Z-score is. All right, so in StatCrunch, stat calculator is normal. We're using the standard normal model, so the mean is 0, the standard deviation is 1. I don't know the Z-score. This is where the Z-score was. I don't know the Z-score, but I know that the area in that bottom tail was 10%. So I'm going to change the area there to be 0.1. And now that that's 0.1, I'll hit compute. This should look similar to the picture that we just had on the board with Z. And I can see right here that when the area in the bottom tail is 10%, that corresponds to a Z-score of roughly negative 1.28. And so now I'm going to turn the lights back on and go back to my z-score formula, plug that in, and solve for the standard deviation. In the next couple of problems, I'm going to ask you to pause the video and practice doing this, practice putting in an area and figuring out the z-score. So make sure that you know how to do that. In the next couple of problems, I'm just going to ask you to pause and recall, give you the answer rather than flipping back and forth. All right, so let's finish up this problem. We just found out that z was negative 1.28. That was the z-score for an apple that weighed 80 grams. The mean is 100. We are looking for the standard deviation. So now this is just algebra. And you ought to be pretty proficient at this point. If we simplify the numerator, I can multiply both sides by sigma, and then divide both sides by that negative 1.28, a negative divided by a negative. That standard deviation must be positive. If you were to come up with a negative answer, I hope that you would know that that's not correct. And if you work this out, the standard deviation is about 15.625 grams. So that's part A. All right, let's move on to question B. For these same apples, give the 90th percentile and explain what it means. All right, recall your picture from part A. Here was 100, here was 80. 10% of the apples were smaller than 80 grams. 80 was the 10th percentile. If you sort of use symmetry, if 80 was the 10th percentile, this is 20 units away, 20 grams below 100. If I went 20 grams above 100 at 120, use symmetry with the normal model. If this area here is 10%, the area of that tail ought to be 10% as well. And if that area is 10%, then the area to the left, 90% of the apples are smaller than 120 grams. So 120 grams would be the 90th percentile. And so for that, we simply use symmetry. It would not be wrong if you wanted to find the z-score for 120 and then work our way through our z-score formula like we did before. Should erase that from the previous part. But that's it for B. B, we can almost use the results from A and symmetry of the normal model to solve. All right, let's go on to C and D. C and D are great problems. They kind of pull in everything that you need to know about the normal model along with some review of your algebra skills. So still working with apples. It's still these Granny Smith apples that average 100 grams. I'm sorry, that's what the original problem was. In C, we have a different kind of apple, forgot. Fuji apples also follow a normal distribution. But this time, the mean and the standard deviation are both unknown. Clearly, they'd be different because it's a different type of apple. Consumers still bypass any apples weighing less than 80 grams. And for Fuji apples, that happens for 15% of apples. We have an additional fact here for Fuji apples. The heaviest 5% weigh at least 1.5 grams. Find the mean and the standard deviation for the Fuji apple model. So now we'll have two things that we don't know what they are. Okay, you've got this written in your notes. I'm going to go to a clean slide to do the work, and I'll be referring back to the information here. So the first thing that we want to do is we want to draw some pictures. Okay, so we don't know what the mean is, we don't know what the standard deviation is. We're going to start with pictures of the standard normal model. So first, let's use the fact that we know that 15% of apples are too small. Now, just like in the problem in part A, I wanted to figure out, well, what's the z-score that corresponds to that? So I'm going to go right to the standard normal model, centered at 0. And if 15% are too small, let's figure out what z-score that corresponds to. I know it's going to be negative. You should be able to pause right now, go over to StatCrunch. In StatCrunch, the mean is 0, the standard deviation is 1. We want to know what's the z-score, what's the probability that x is less than or equal to, leave that blank, when that area is equal to 0.15. And when you compute, you should find that this z-score right here is negative 1.04. And we know that that corresponds to a weight of an apple of 80 grams. So we'll use that fact in just a second. Okay, the second thing that we know is that the heaviest 5% weigh at least 105 grams. So 5% or 105 grams or more. Let's draw another picture. Again, we're still going to stick with the standard normal model for now. Five percent of the apples are heavy. We don't know what the average is here, but if 5% of them weigh that amount or more, the average has got to be smaller if we were actually looking at the weights, not the z-scores here. So we've got some kind of z-score here, don't know what it is, where the area out in this tail is the top 5%. Again, pause the video, go to StatCrunch, type in a mean of 0, standard deviation of 1. This time, we're trying to find what's the probability that x is greater than, and leave that blank, when the area out in that right tail is 0.05. You should get, you look at your picture, you better get a positive z-score, otherwise you didn't type something incorrectly there. This corresponds to a z-score of 1.64. All right, so now let's go back and use our z-score formula and see what we can do with these z-scores. Since I'm over here, I'll continue with this one. This z-score of 1.64, that corresponded to an apple that was 105 grams. But we do not know the mean. We do not know the standard deviation. So here I'm kind of stuck. If we jump back to the apples that were too small, we can do the same kind of thing. A z-score of negative 1.04, that corresponded to the apples that were too small. They were too small if they were 80 grams or smaller. Again, we do not know the mean. We do not know the standard deviation. All right, so I have this equation, and I've got that equation. This is like flashback to algebra class. Pretend that mu and sigma, pretend they're x's and y's. You have two equations and two unknowns. From algebra, you should have been able to solve these in many different ways. I'm going to show you one way to solve this one, but if you learned how to do it a different way, do it your way, and you should end up with the same answer as long as you do everything correctly. What I'm going to do, I'm going to take each of these equations, I'm going to solve them both for mu. I'm going to solve that one for mu. And then once I have mu equals, I'm going to set the two of them equal to one another, and we'll be able to eliminate a variable. So I'm going to erase my picture at the top here, and the next thing I'm going to do is solve each of these equations for mu. If you need help with this algebra part, you should come see your instructor. You should go to the math lab. I'll go through this fairly quickly because you should have these algebra skills. But if this is hard for you, get some help. All right, so let's solve for mu. I'm going to multiply both sides by sigma. I can add mu to both sides. I can even add this to both sides. So I multiplied both sides by sigma. I added mu to both sides. I added this quantity to both sides. And here I am with this one, mu equals. I'm going to do the same thing over here. Multiply both sides by sigma. Over here it'll cancel. I'm going to add mu to both sides. I'm going to subtract this from both sides. And now I have mu equals. All right, so mu equals this, mu also equals this. Therefore, I can set those equal to one another. So now I'm going to pull these two together. And once you've done that, you now have one equation with one variable that you don't know. And I hope that this is pretty simple for you to solve here. I'm going to get sigma on the left and the other coefficients on the right. So I'll add 1.64 sigma to both sides. Oops, that's a sigma. And in the same step, I'm also going to subtract 80 from both sides. And if we simplify this, this is 2.68 sigma. This will be 25. And now I can divide both sides by 2.68, and I have the value of sigma. I gotta look that one up. If you do that, you should get 9.33 grams. That is the standard deviation for these Fuji apples. So we're halfway there. The good news is to get mu, that's easy now. So here's the standard deviation. We still need to know what's the average weight of those apples. Take either one of your equations for mu, plug back in the value of the standard deviation. You could do them both. You really don't need to. Take either one of those, plug in the value of sigma, and we'll find out what the average weight is. So I'm going to sneak that up here. You should draw this, keep going sequentially in your notes here. But the next step is to plug sigma back into the equation for mu. I'm going to use this one just because it's right here. And so when I let sigma be 9.33, you will get 89.7 grams. Got a little bit crowded there, but so those Fuji apples, you have this now in your notes. I'm going to get rid of that. Make sure I spell Fuji right. Those Fuji apples followed a normal distribution with a mean of 89.7 grams and a standard deviation of 9.33 grams. And so this was one where we didn't know either one of those to start, and now we have them both. So a little bit of a longer problem, but it combines what we've learned with the normal model, refreshes your memory on some of your algebra skills. All right, we've got one more just like this one to practice. If you would like to pause the video and try D all by yourself, that would be fantastic. Try to do it yourself and then unpush pause and check your work here. So we're going to do what we just did one more time. And then this one will be done. All right, D. Here we go. We've got a new kind of apple, Macintosh apples. Have a 25% chance of being bypassed by consumers. So 25% chance of being under 80 grams, a 2% chance of exceeding 100 grams, A normal model applies. Again, find the mean, find the standard deviation. So our strategy here, we're going to figure out what z-score corresponds to the small apples, what z-score corresponds to the large apples, and then we'll use the two z-score formulas to help us solve for mu and sigma. So again, if you want to pause and see if you can set this one up. But the first thing, we need two z-scores. So draw yourself two pictures here. First one is the small apples. I need a z-score, so I'm going to still stick with the standard normal model. The small apples are down here. There's a 25% chance of being bypassed. So this area this time is 0.25. 25% of them are too small, so I need to figure out what z-score that goes with. The other z-score that I need was for those large apples. 2% exceed 100 grams. So 2%, that's not very many of them here, exceed a certain weight. What z-score does that correspond to? So again, I'll talk you through this, and then I'll give you the answers for these. You can use StatCrunch to find these. To find this z-score, you would go into StatCrunch. The mean is 0. The standard deviation is 1. We're looking for the probability that x is less than, we don't know, leave that box blank, and that area equals 0.025. Make sure you get a reasonable z-score. My picture tells me it better be negative. And if you do this z-score, whoops, better be negative, and I forgot the negative, is about negative 0.067. All right, same thing for the larger apples. Go into StatCrunch. The mean is 0. The standard deviation is 1. We want to know the probability that x is greater than, we don't know what value, it's actually z is greater than, and then that area is going to be 0.02. Again, you'd expect this to be a reasonably large z-score. The area out here is only 2%. You can almost think back to your empirical rule and kind of guess what this might be, but this corresponds to a z-score of slightly more than 2, 2.05. Okay, so now we have our two z-scores. I'm going to go ahead and set up those two z-score formulas. And again, there's multiple ways to solve those, but my strategy is going to be to solve both of those equations for mu. And we'll go from there. So let me get a blank page here. So my first z-score was negative 0.67. That corresponds to the small apples that only weighed 80 grams. We do not know the mean. We do not know the standard deviation. Okay, so there's one z-score formula with what I know filled in. Let's do the other one. The large apples, the z-score was 2.05. Large for the Macintosh was exceeding 100 grams, so the weight of the apples was 100. Again, still do not know the mean, still do not know the standard deviation. And again, two equations, two unknowns, lots of ways to solve this. My strategy is going to be to solve both of these equations for mu and then set the equations equal to one another. All right, so if you take this equation, solve for mu, multiply both sides by sigma. I'm going to add mu to both sides because it's negative, and I'll add this to both sides. that equation solved for mu. I'll do the same kind of thing over here. Multiply both sides by sigma. And then I'm going to add mu to both sides. I'll subtract this quantity from both sides. Again, there's even multiple ways you can do this, but this is what I'm doing. And now we know mu equals this quantity, mu equals this quantity. We'll set those two quantities equal to one another, and we'll be able to then solve for sigma. So let's set these equal to one another. I need to get the items with sigma on one side and the other constant terms on the other side, so I'm going to add 2.05 sigma to both sides. And at the same time, I'll subtract 80 from both sides. And then we're going to combine like terms here. Make sure you have all this that's on the board. If you don't, go ahead and pause. I'm going to erase some of this and start up at the top. So you would just continue in your notes here. If we add these together, just checking my math. If we add these together, we're going to get 2.72 sigma. And 100 minus 80 will have 20. And divide both sides by 20. Sigma is about 7.35 grams. Almost finished. That's the standard deviation. We still need to know the mean. Take either equation. If you really want to, you could do both, but it'll get the same answer. Plug in the value of sigma, and out should come the mean. So again, I'll use this one. And if I take the value of sigma, finally here, I get a mean of 84.92 grams. And so for these, this time it was Macintosh apples, they follow a normal model. The mean is 84.92. The standard deviation is 7.35. So kind of a long problem, but a nice one. They tie in everything we've learned about the normal model along with some of your basic algebra that if you needed to brush up on, that might have been a good idea. And man, I hope that's it for this one. This was a little bit long, so that's it. We'll see you in class.